All right, so we're on to our last motor efficiency problem. In the previous two, we were looking for the efficiency of the motor and the input of the motor, and in this one, we're going to be looking for the output. So a certain motor requires 1.12 kilowatts of electrical power to operate and is only 85% efficient. So right off the bat, we know that we're given the efficiency. And when we're given the amount of electrical power that's required to operate, we're given the input to the motor. And we're being asked, what is the total output of the motor in horsepower? So here we're being asked to provide our answer in horsepower. We're given watts or kilowatts, and we know we're going to have to do a conversion later on. And we're given the conversion factor here of 1 horsepower equals 746 watts. So just like all the previous ones, we want to write down our efficiency equation, which is efficiency equals output over input. And we just write down what we know. So input here is going to be the 1.12 kilowatts. The efficiency is going to be 85% or 0.85 expressed as a decimal. And again, we don't know the output. That's what we're looking for. So now that we have all of our variables identified, we just need to plug these guys into this equation. And so efficiency here is going to be 0.85. And then output is going to be on the top. We don't know it, so let's just keep it as output divided by the input. And in this case, the input is 1.12 kilowatts. Now, we don't have output by itself now. We need to isolate output and essentially solve for it. And so, because this is a division problem, I need to cancel that out with a multiplication problem. That's what that dot's for. So we multiply times 1.12 kilowatts, and we do that on both sides to maintain the equal. So 1.12 kilowatts. That's going to cancel this out, and that leaves us with 1.12 kilowatts times 0.85 is going to be equal to our output. And now we just jam that into the calculator here. So 1.12 EE3 times 0.85. And remember, our calculator gives us our base units, and so this is 952 watts, not kilowatts. It's important to remember that. So 952 watts equals our output. Now, because we're talking about a motor, and motors output kinetic energy, we're really wanting to or kinetic power, we're wanting to understand that value in horsepower, units of horsepower, not units of watts. And we were specifically asked to provide the answer in horsepower. So we need to convert watts over to horsepower using this conversion factor here. So when we set this up, we just say 952 watts. And if it helps to remember that this is just a fraction over 1, right? That's all equal to itself. We went over that in previous videos. Times some other fraction that is also going to be equal to 1, and that fraction is this conversion factor here. And so we got to remember, whichever one we're trying to cancel is the one we put on the bottom. So we're trying to cancel out this watts and convert it over to horsepower. So we put 746 watts on the bottom and 1 horsepower on the top. And hopefully we can see that this problem becomes 952 divided by 746 because the ones just cancel out, right? So if we were to rewrite this, we get 952 watts divided by 746 watts times 1 horsepower. And if we do this calculation, that's 952 divided by 746 equals 1.276, we'll call it 1.28. equals 1.28 times 1 horsepower. And so this is where we get our unit from. And so this just becomes 1.28 horsepower. And this is our answer for output. Okay, and that would just get plugged in right there. So pretty straightforward. It's a plug and chug type problem. The hardest thing to identify is making sure we understand what's input, what's output. The efficiency is pretty self-explanatory because we pretty much say that it's efficient. The input and the output, differentiating between those, is really the stumbling block for most of you guys working these problems. But if you can get that kind of parsed out and label everything, right? Write down our efficiency equation and then write down what we know and get those in the right places. Everything else is just plug and chug, right? And I highly encourage you to write everything out. And when you've gone over this in class, write everything out so that when we get to a point where we actually have to do some math and put it in our calculator, we can clearly see what we're putting in our calculator. Most issues with these math problems are made when we're trying to translate from here to here too quickly. When we're trying to go from an equation and punch these numbers into our calculator too quickly without having it laid out first, and we mistype something, or we miss a keystroke, and it throws the whole problem off, and we can't see it. When we write it out, it's more easily to identify the problems, more easy to identify the issues that we're having putting it into the calculator before we ever get there, all right? So if we remember those key steps, you should have no problem with motor efficiency.